Amateurs talk about tactics. Professionals talk about logistics. This is the oldest maxim in military history, and yet, when we look at the Roman Empire, we almost always focus on the tactics. We obsess over the testudo formation, the gladius, the heavy infantry, and the genius of Caesar. But Rome did not conquer the known world simply because they were better at stabbing people. They conquered it because they engineered a solution to the fundamental problem of warfare, the tyranny of distance. To the modern observer, the Roman road, the Via Appia, the Via Flaminia, is a piece of civil infrastructure. It is a tourist attraction. We view it as a trade route designed to move olive oil, wine, and pottery. This is a civilian misconception. To a military strategist, a Roman road is not a road. It is a weapons system. It is a piece of military hardware designed for rapid force projection. It is a mechanism of control, designed to strangle insurgency and allow a centralized power to project violence to the periphery of the map at speeds the ancient world considered impossible. The legions were the projectile, but the road network was the delivery mechanism. Without the network, the legions are just isolated groups of men stuck in the mud. With the network, they become an omnipresent, inescapable force. In this analysis, we are going to deconstruct the Roman road system. We will not look at it as a marvel of tourism, but as a doctrine of domination. We will look at the engineering specifications, the operational tempo it enabled, and how this ancient technology laid the blueprint for the modern U.S. interstate highway system. To understand the solution, we must first understand the problem. In the ancient world, geography was the ultimate enemy. Before the paving of Europe, warfare was dictated by the seasons. This is a concept known as seasonal warfare. Campaigns were launched in late spring when the ground dried out. They were fought during the summer, and they ended in the autumn when the rains returned. Why? Friction. Moving an army of 20,000 men, thousands of horses, and tons of equipment across unpaved terrain is a logistical nightmare. When it rains, dirt tracks turn into mud. A heavy ox cart carrying grain sinks to its axles. Horses break their legs. The march speed of an army drops from 10 miles a day to 0. If you were a barbarian chieftain in Gaul or Germania, the mud was your best defense. It bought you time. It meant that if you rebelled in November, Rome couldn't touch you until May. Rome realized that to become a superpower, they had to break the cycle of the seasons. They needed all-weather warfare. They needed the ability to deploy a heavy infantry force anywhere in the empire, at any time of year, regardless of the weather conditions. This required a complete terraforming of the landscape. They couldn't just clear a path. They had to build a platform that isolated the army from the friction of the earth. The resulting engineering doctrine was the Via Munita, the paved way. It is a mistake to think of these as roads in the modern sense. A modern asphalt road is a layer of surface material laid on top of the ground. A Roman road was a wall buried in the ground. The construction process was brutal and methodical. Legionaries, not slaves but soldiers, would dig a trench down to the bedrock or solid clay. They would then fill this trench with 4 distinct layers of material. First, the statumen, a foundation of large stones hand-fitted together to provide a solid base. Second, the rudus, a layer of rubble and concrete to provide shock absorption. Third, the nucleus, a layer of fine gravel and sand to level the surface. And finally, the pavimentum, the large interlocking polygonal stones that we see today. But the most critical feature of this engineering was the agger. Roman roads were rarely flush with the ground. They were built on a raised embankment, often 1 to 2 meters high. This served two critical military functions. First, drainage. By elevating the road surface and curving it slightly, water would run off immediately into ditches on the side. This guaranteed that while the surrounding fields were a muddy bog, the road remained a dry, hard surface. This is the key to all-weather operations. Second, defense. A marching column on an agger is permanently on the high ground. If an ambush occurred, the legionaries were physically above their attackers. They could form a shield wall on the edge of the road and force the enemy to fight uphill. The road itself was a fortification that stretched for thousands of miles. Then there is the geometry, the famous Roman straight line. We often hear that Romans built straight roads to save time. While true, there is a psychological component to this engineering. In nature, nothing is straight. Animal tracks curve, rivers meander. By cutting a dead straight line through forests, mountains, and valleys, Rome was sending a message of dominance. They were not negotiating with the terrain. They were conquering it. For a local tribe, seeing this massive artificial scar cutting through their ancestral lands was a daily reminder that a foreign power had total control over their environment. So, what was the return on investment for this massive expenditure of labor and capital? The answer is operational tempo. In military doctrine, tempo is the speed and rhythm of military operations relative to the enemy. The Roman road network gave the legions a speed differential that was insurmountable. An enemy force moving cross-country might manage 8 to 10 miles a day, struggling with foraging and terrain. A Roman legion on a paved road could maintain a standard march of 20 miles a day. On a forced march, they could hit 30 or even 40 miles. Over a campaign of 2 weeks, this difference is catastrophic for the enemy. It allowed Rome to utilize internal lines of communication. Because Rome controlled the network, they could move troops from a quiet front to a hot front faster than the enemy could react. A revolt in Gaul could be met by 3 different legions converging from 3 different directions before the rebel leader had even consolidated his forces. Furthermore, the road solved the supply chain equation. An army marches on its stomach. A single legion requires tons of grain and fodder every single day. Without a road, you are limited to what you can carry or what you can steal from the locals. This limits your range. With the road, heavy ox carts could follow the infantry. Rome could project power deep into enemy territory because they brought their logistics with them. They didn't need to stop to forage. They didn't need to wait for the harvest. They were a self-contained machine of destruction fueled by a supply line that stretched back to the heart of the empire. This network also acted as an information superhighway. The cursus publicus, the state courier system, used relay stations every 10 miles to swap horses. Intelligence could travel at 50 miles a day. The emperor in Rome knew about a barbarian incursion weeks before the barbarians reached a major city. Rome was always inside the enemy's decision cycle. If this doctrine sounds familiar to a modern American audience, it should. The Roman road network is the direct spiritual ancestor of the U.S. interstate highway system. In 1919, a young U.S. Army officer named Dwight D. Eisenhower participated in the Transcontinental Motor Convoy. It was an experiment to see if the Army could drive from Washington, D.C. to San Francisco. It was a disaster. It took them 62 days. Vehicles broke down in mud, bridges collapsed, and the convoy averaged 5 miles per hour. Eisenhower realized that in a real war, the United States was immobile. Years later, during World War II, Eisenhower saw the German Autobahn. He saw how the Germans could shift reserves from the Eastern Front to the Western Front with terrifying speed. When he became president, he signed the Federal Aid Highway Act of 1956. Most people know it as the Interstate system, but the official name is the Dwight D. Eisenhower National System of Interstate and Defense Highways. Like the Roman roads, our highways were not built for family vacations or commerce. Those are just side effects. They were built to mobilize the military, to move tanks and missiles across the continent, and to evacuate cities in the event of a nuclear exchange. The specifications, bridge heights, lane widths, grade curves, were dictated by the Pentagon, just as the Roman specifications were dictated by the legions. The U.S. Interstate is the Via Appia of the 20th century. The lesson of the Roman roads is that infrastructure is destiny. A superpower is not defined solely by its ability to inflict damage in a single battle. It is defined by its ability to sustain operations over vast distances and long periods. The Roman legionary is often depicted holding a sword, the gladius, and a shield, the scutum. But the most important tool he carried was the delabra, a pickaxe. They won wars with shovels. They defeated enemies by altering the geography of the battlefield to suit their needs. The road network was a force multiplier that made one Roman soldier worth 10 barbarians, simply because that Roman soldier could be exactly where he was needed, fully fed and fully equipped at the exact moment the commander needed him. However, there is a final, darker lesson in this doctrine. Infrastructure is neutral. It does not care who uses it. In the final days of the empire, when the legions were weak and the borders were overrun, the Roman roads did not disappear. The Visigoths, the Vandals, and the Huns found a paved, high-speed network leading straight to the capital. The very mechanism that allowed Rome to export violence to the world eventually allowed the world to bring violence to Rome. The stone noose that Rome built to strangle its enemies eventually tightened around its own neck. But for 500 years, it worked. It proved that in the calculus of empire, the road is mightier than the sword. If you enjoyed this analysis of military logistics, make sure you are subscribed. We break down the mechanics of power, not just the dates and names. And if you want to understand how Rome applied this engineering mindset to the ocean and why it failed miserably before it succeeded, click on this video right here. Rome lost more men to storms than to enemy fleets, and the reason comes down to bad engineering. I'll see you in the next briefing.